Okay, so finally we're on the last part of 5.4, part 4, sort of wrapping up everything with factoring and solving polynomial functions. So take a look at the problem of the day. I want you to factor completely. Make sure you pause the video, and don't forget that this is the first problem in your homework at the end of the lesson. So where does that lead us in the lesson right now? What have we done so far? We learned over 2 days, or 2 parts, we've learned 4 different types of factoring. Last lesson, part 3, we ended up sort of grouping them all together to sort of have like a chart to let you know when to use what method. And now finally, we're adding one last part to it. We're going to get more of a review of factoring again, like the last lesson, but now we're going to set them equal to 0. So there's one final part, putting everything together that we've learned in 5.4. So example 5 says find all zeros. What changes here is, and we've done this in chapter 4 with quadratics, once you factor, so say you did this problem and you've got all 3 parentheses here, the new part is you're going to set it equal to 0. Now f of x, don't let that confuse you. That's just y, function of y. We plug in 0 for it. From here, we're going to set each parenthesis separately equal to 0. So if x minus 1 equals 0, 2x plus 3 equals 0, x plus 2 equals 0. So you have 3 separate one-step equations. X will equal 1. But be careful with this one. Oh, I have work here. I'll go back for a second. Bring the 3 over as a -3. We divide both sides by 2. We get x equals -3 halves. Here we subtract 2 from both sides. We get x equals -2. So my final answer for this one is x equals 1, -3 halves, and -2. So the first type of problems you'll see, starting off basic, is they already factored for you. You just set each part equal to 0. Well, now what's it going to look like sort of throwing everything together in this whole lesson, where you factor and then solve? So example 6, find the real number solutions to the equations. All right, let's take a look at A. And if you need your chart, go back to that as well. If we look in our chart, 2 terms, we can actually factor out a GCF of y squared. So factor out the y squared, we're left with y minus 5. Now, I can't factor anything further, so I'm going to set y squared equal to 0 and y minus 5 equal to 0. So y squared equals 0, y minus 5 equals 0. On the one on the left, opposite of a square, is a square root. So square root both sides. Either way, you're still just going to get 0, right? And we add 5 to both sides, y equals 5. So in this case, I have 2 solutions. I have y equals 0, and y equals 5. All right, so let's look at B. If we go back to our chart, we have a trinomial. We have 3 parts. So the only way we could do that is factoring. But if you notice first, don't they have a GCF we could factor out like a monomial? They all have 4 in common. So let's go about the route of factoring out your 4. We're left with w to the 4th plus 10w squared minus 11. And now when we factor this, w to the 4th will be w squared in each parenthesis. What do we know here? Signs are different, right? So let's look at the next line here. W squared in each, signs are different. 11 is 11 times 1. Why do we want the positive 11 and negative 1? 11 minus 1 is positive 10, which is the middle term. Now, ask yourself, can you factor further? Think for a second. And these are the kinds you'll see a lot actually in this lesson. You could factor this one further. This is a difference of 2 squares. Comes this. 4 times w squared plus 11 times w minus 1 times w plus 1. And now we're going to set each equal to 0. Oh, and before I do that, I want to add something here. See how there's a 4 here? We could divide this whole side by 4, where it'll cross out, right? But what's 0 divided by 4? 0. So this actually goes away because there's no variable, because it's a single number. From there now, we set them each equal to 0. This will be w squared equals negative 11. Take the square root of both sides. Don't forget with this one, what happens When we take the square root of a negative number, think back to chapter 4. First of all, it's a plus minus, and the negative comes out as an I. So you get plus minus I root of 11. This will be 1, this will be negative 1. Now, that will be our answer. One thing I do want to add to it, though, if you notice up top here, it says find the real number solutions to the equations. Is this I a real number? Hopefully you remember, it's imaginary is not. So yeah, we did the work to it, but we're going to actually cross it out because it doesn't count. We want real number solutions. All right. So let's take a look at our last set of examples here. We have one last one for the lesson finally. And honestly, I don't think it's a bad idea to pause the video and solve them yourself, other than me solving them for you. Letter A, well, there's 4 terms, so you should be doing grouping. Be careful with B. Do you see how B is not equal to 0? So we actually have to transpose the 18x cubed over. Now for grouping. So we could take out of each. First group, we could take out a g squared times the quantity g plus 3. Second terms, we could only take out a negative 1, g plus 3. Put the coefficients in one parenthesis, what repeats in the other. Now, always ask yourself, can you factor further? Yes, you can. You could factor this further. It's the difference of 2 squares. So I wanted to fix one thing here. You can factor the g squared minus 1 further. So that is a difference of 2 squares, right? So I just get my pointer here. It's g plus 1 times g minus 1. Bring down the g plus 3. And now I can finally set them each equal to 0. And as our final answer, we get negative 1, 1, negative 3. All right. So one last one here. We first have to actually, it always has to be equal to 0. So we're going to take that 18x cubed and move it over, and we're going to move it after the 3x to the 5th because we want it in standard form. So we get this, 3x to the 5th minus 18x to the 3rd plus 15x. From here, what do you notice? Do they have a monomial you could factor out? They have a 3 and an x, so we factor that out. Now what's in parentheses is 3 terms, so I can factor. X squared in each, signs are the same, they're both negative. We want 5 times 1. 5 times 1 is 5, negative 5 minus 1 is negative 6. Can I factor further? Yes. And you'll notice a pattern. A lot of times the ones that you can factor further are the difference of 2 squares, which are these. You might ask, well, how come I can't factor this one further? It's because 5 is not a perfect square. Now, do you remember in the last example where, I don't think I have it up now, right here, because the 4, we were able to cross it out, because you divide both sides by 4, 0 divided by 4 is 0. You can't do that here because it's an x. You actually have to set them each equal to 0. Don't forget the negative 5 comes over as positive. We take the square root, it's plus minus. So you get 0 plus minus root of 5, negative 1, and positive 1. And that's our answers. So we have what? 1, 2, 3, 4, 5. Now, rule of thumb, it doesn't work 100% of the time, but your highest degree, or your degree or your highest exponent, which is 5, how many solutions do I have? I have 5. Here's 3. I have 3. All right, that's it for the lesson. Make sure you are completing the problems to do your check work before we come to class. Problem of the day from the beginning. And then I'm only giving you 2 problems I want you to try on assignment 10, 2 and 12.